Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to continue in this series on an introduction to thermochemistry. In this particular video I'm going to talk about specific heat. So first, a few reminders. One, that Kelvin is a unit of temperature. So I will talk about Kelvin scale. I'll talk about Celsius. So we don't say degrees Kelvin, we just say Kelvin. So if the temperature is 273, we say 273 Kelvin. We say if it's Celsius, it's 273 degrees Celsius. So Kelvin is a unit of temperature, and the Kelvin scale is the absolute zero scale, which means that at 0 Kelvin, there should be no molecular movement whatsoever. And we say 0 K or 0 Kelvin. We've never really gotten to 0 Kelvin, but we've gotten really close. And another reminder is that this equation here is helpful for converting between Kelvin scale and degrees Celsius. So K is equal to whatever degrees Celsius they give you plus 273, or to get degrees Celsius from Kelvin, you subtract 273. In thermochemistry, we are going to be using degrees Celsius, not Kelvin. Okay, let's move on. So now that we got the reminders out of the way, let's talk about specific heat. So specific heat, that is the question regarding how much heat can something absorb, right? So different substances are able to absorb different amounts of heat without raising their temperature very much. Some substances can't absorb a lot of heat without their temperature going up. So what is specific heat? Specific heat is the amount of energy it takes to raise the temperature of 1 gram of substance. That's where the specific comes in, right? If this was just heat capacity, then instead of specific heat capacity or specific heat, then this 1 gram wouldn't be there. It would be whatever the amount that you are looking at. But we need to specify what the amount is. And here we're being specific to 1 gram. So it's the amount of energy it takes to raise the temperature of 1 gram of substance by 1 degree Celsius. And so that is what we mean by specific heat or specific heat capacity. And what are the units? Well, as you would imagine, based on the definition, it's going to be an energy unit, joules. So the amount of energy in joules divided by the grams and then divided by the degrees Celsius. So it's joules of energy per gram per degree Celsius. And so these are the units. And this is really important because the units can be very helpful in giving us a hint of the calculations. So for example, if I want to know how much energy was absorbed by a certain substance, and I know the mass of it, and I know the temperature change, then I can use the specific heat to find the amount of energy that was absorbed or lost by the substance. Because notice here that if I have a joule unit, this is an energy unit in joules. So if I want the amount of energy, well, the energy is measured in joules. So I don't want grams and I don't want degrees Celsius. I just want joules. Well, how do you get rid of grams and degrees Celsius from this here? Well, since grams and degrees Celsius are on the bottom, then you multiply by grams and degrees Celsius to get rid of them. So if I can measure, if this is specific heat and these are the units, then this indicates that all I need to do is take the specific heat, multiply it by a mass in grams, that'll cancel out the grams, and then I multiply it by degrees Celsius or a temperature change, and I'll get rid of degrees Celsius. I'll be left with joules. So that's the equation to find the amount of heat that is absorbed or lost by an object. So let's move to that in just a moment. Okay, So here's our equation. Q equals MCAT. That is our equation. Q equals MCAT. So Q is equal to energy lost or gained. So Q you can think of as quantum of heat or quantum of energy, Q. So here our quantity of heat or quantity of energy, right? So here Q is equal to the energy that is lost or gained by the object or whatever the system is, right? And then here M is for mass, and that's going to be in grams. And then C is for specific heat. And this triangle means that's the delta sign. That's the capital delta for Greek symbols. And so here, this delta means change. So anytime, a lot of times in science, you're going to see a delta. Sometimes it means heat. If it's written over the arrow of a chemical reaction, in that case, it means heat. But a lot of times when you see a delta in equations, it means a change. So here, delta T means change in temperature. And the change in temperature is always going to be the final temperature minus the initial. So F final, I initial. So final temperature minus the initial temperature. So if we submit or substitute this in for delta T, then we get the quantity of heat that's lost or absorbed by the system or the object or the substance is going to be equal to the mass in grams multiplied by the specific heat and then multiplied by your change in temperature. And so since your specific heat is in units of joules over grams over degrees Celsius, then when you multiply by mass in grams and you multiply by change in temperature, those will cancel out and leave you only with joules, which is an energy unit, which is exactly what you would expect for Q, which is your quantity of heat absorbed or lost by the system. Okay, well, let's talk about negative versus positive Q values. Okay, so let's talk about whether your Q value is going to be positive or negative, or your delta T. So here we're trying to find the Q value, whether or not how much your system has gained or lost energy. So if we have this table here, so if we're gaining heat, that's an endothermic process or endothermic reaction. So therefore, the temperature change is going to be what? If you're gaining heat, that means your temperature is going to go up from the initial temperature. So when you do your final minus initial, your final temperature is going to be larger than your initial. So when you subtract them, you're going to get a positive value for your change in temperature. So this should be positive. If your temperature change is positive, then when you multiply your mass, which is always going to be positive, there's no such thing as a negative mass, and your specific heat, that's always going to be positive as well, because there we're talking about the amount of heat that can be gained by a substance. So you're not going to have negative values for your specific heat. And so if your temperature change is positive, then your Q value, the quantity of heat, is going to be positive, which means that heat was gained by the system. Okay, what if your system loses heat? Then that is exothermic. It's losing heat. And so in that case, if you're losing heat, that means the temperature is going to go down, right? So if the temperature goes down, then your initial temperature is going to be larger than your final temperature. So when you subtract your final minus initial, if you do that, then you're going to end up with a negative value for your delta T. Okay, and then in this case, your quantity of heat is going to be negative, and that's going to indicate that the quantity of heat was lost by the system. So the positive and negative values mean something, and it's important to keep track of your positive and negative. So again, if you get a Q value that's positive, that means your system gained energy, heat. If your Q value is negative, that means it lost energy or heat. Okay, well, let's talk more about how to show your work when you're doing problems. Okay, so let's talk a little bit about showing work. So you got a couple of choices here. So for units, you can either put the units into the mathematical equation, right? So I have my Q equals, I'll write it up here, Q equals MCAT MC delta T, and I can plug everything into the equation directly and solve it that way. I prefer this way myself because I can see that the units cancel out, grams will cancel out, and then joules will end up canceling out when you do the math. And so you should end up with your degrees Celsius as the unit. If you don't wind up with degrees Celsius as a unit, then you know you did something wrong or you made a mistake somewhere and you can check your work. Or another way is you can prefer to write down a list of the information and data that they gave you and then plug in the numbers into the equation. I think this is a fine way to do it. However, again, I would prefer to have the units in there so you can see what cancels out. But these are a couple of different ways you can use and show your units. As far as algebra goes, a couple of different ways you can do this. You can show the rearranging of the problem once you put the numbers in. So I could, here I'm solving for the change in temperature, delta T. So I can plug my numbers in and then I can rearrange the equation. I could do the math. I could divide both sides by these numbers, or I can multiply these together and then divide, right? So I can show that work with the numbers in, or I can solve the equation for the missing part, right? So here's my equation. Since I'm looking for delta T, I can just solve this equation for delta T first, like I did here. So delta T would be equal to Q over MC. And then I can take my data here and plug them into the equation and solve it that way. So there's a couple of different ways that you can show your work on these sorts of problems. Let's go over now some example problems. So get ready to be solving some Q equals MCAT problems. Okay, so here's our practice problem number 1 using our Q equals MCAT equation. So we're asked how much heat is needed to raise the temperature of 10 grams of a substance from 40 degrees Celsius to 60 degrees Celsius if the specific heat is 3.8 joules per gram degree Celsius. Okay, so let's list our information. So we're given the mass. So here's our grams. We got 10 grams of mass. We've got our initial temperature, and we got our final temperature, and we have our specific heat. So we have, let's list this. So we want to find Q. Q is what we're looking for. We know our mass. The mass is 10 grams. And we know the initial temperature, T, I, and that's 40 degrees Celsius. And we know our final temperature, T sub F, that's 60 degrees Celsius. And we know our C, our specific heat, which is 3.8. So 3.8 joules per gram degree Celsius. So we got our list of items. So we just plug this into our equation. So Q is going to be equal to the mass, which is 10 grams. So 10 grams multiplied by specific heat. So here we have our 3.8, and that's joules per gram degrees Celsius. And we have our temperature change. So the temperature change is final minus initial. So 60 degrees Celsius minus 40 degrees Celsius. And so there's everything laid out. So grams on top, cancel out grams on the bottom. The Celsius, degrees Celsius on top will cancel out with degrees Celsius on the bottom. So what we have left is our joules, which is a heat energy unit. So that matches what we're trying to find, Q. Okay, so then all we need to do is solve this on our calculator. And when you calculate this, you get Q is equal to 700, let me double check, 760 joules of energy. And notice that Q is positive, which means that it's an endothermic reaction or process. And so that makes sense because notice that our temperature increased from 40 to 60, and that's because there was a gain of energy by the substance. So we would expect a positive Q since we had a positive change in our temperature. Okay, let's go over practice problem number 2. Okay, so here is practice problem number 2. A 50-gram piece of metal or hot metal is put into cold water. The metal transfers 5,000 joules of energy to the cold water. The specific heat of the metal is 6 joules per gram degree Celsius. What is the change in temperature of the metal? So first thing we need to realize is that this is from the perspective of the metal. So the metal is our system. So we want to make sure that we're putting in the values as the metal is the system from the metal's perspective. So let's go ahead and circle the information we're given. And so here we're given 5,000 joules of energy, metal that's transferred from the metal to the cold water. So that's going to be important for later. The specific heat of the metal is 6 joules per gram degree Celsius. That's quite a large specific heat for a metal. And we're given the mass of the metal as 50 grams. Okay, so let's list what we've given. Oh, and we're looking for the change in temperature. So what is the change in temperature? So Q. What is Q? Q is the quantity of heat lost or gained by the system. Our system is the metal. So it's telling us that the metal is transferring 5,000 joules of energy to the water. So if we're looking at this from the perspective of the metal is losing that energy. So that's going to be an exothermic process, and that means Q is negative. So we're going to write down negative 5,000 joules. This is very important because if you don't get this right, you're not going to get the correct temperature change that you want. Okay, so we got Q, and then our M, mass, that's going to be 50 grams. And then we have our C, our specific heat. That's going to be 6 joules. So 6 joules per gram degree Celsius. And then we're looking for the temperature change. So delta T is equal to question mark. So we have everything listed. Let's go ahead and plug it into our equation. So here's our equation. So Q is going to be negative 5,000 joules. And that's going to be equal to the mass, that's 50 grams, multiplied by the specific heat, 6 joules per gram degree Celsius. So 6 joules per gram degree Celsius times the temperature change, which is what we're looking for. So delta T. So now all I need to do is solve for delta T. And so when I divide both sides by grams, right, here we see grams are going to cancel out grams. So I have grams on top, grams on the bottom. So that's going to cancel out. And now notice I have joules over degrees Celsius. When I divide by this on this side, dividing by joules over degrees Celsius is the same as multiplying by degrees Celsius over joules. And so that joules would cancel out. So joules are going to cancel out when I divide, right? So when I take this, right, divide 50, so the grams have canceled out. So it's going to be 50 times 6 joules over degrees Celsius. Divide this by 50 joules over, oops, I forgot the 6 joules over, the grams are gone, degrees Celsius. So now I'm dividing this. Joules are going to cancel out, leaving me with degrees Celsius. And when I calculate that out, I get delta T is equal to a negative 16.7 degrees Celsius. So there's my answer. So that's the change in temperature. And that makes sense because remember, my block, the piece of metal, is the system, and that's losing 5,000 joules. So if it's losing that energy, the temperature is going to go down. I'm going to have a negative change in temperature, which is what I get. So it makes sense. Okay, let's do our final practice problem number 3. Okay, final problem. So, practice problem number 3, a 2-gram sample of a metal was heated from 260 Kelvin to 300 Kelvin. It absorbs 52 joules of energy. What's the specific heat? Okay, so we're looking for specific heat. So let's circle what we've got. We've got 2 grams mass, and we've got initial temperature, final temperature, and we're told it absorbs 52 joules of energy, and we're looking for the specific heat. So if we write this down, Q, what's Q? Q is 52 joules. So what is absorbing the 52 joules? It's the metal. The metal is our system, so it's absorbing heat. That's endothermic, so this is going to be positive. So that's going to be a positive 52 joules. Okay, we have our mass. The mass is 2 grams. We have the specific heat, which is what we're looking for, so that we don't know. And we have the initial final temperature. So the initial temperature, so TI is our 260 Kelvin. And our final temperature is 300 Kelvin. So the first thing we need to do is convert our Kelvin temperature to Celsius, because remember, our specific heat is going to be in terms of degrees Celsius. So we're given Kelvin, we need to convert. So remember the equation, Kelvin is equal to degrees Celsius plus 273. Or if you solve this for Celsius, that's going to be equal to Kelvin minus 273. So we're going to have to subtract 273 from our temperatures. When we subtract 273 from this one, we get, so we subtract 273, and that's going to give us a negative 13 degrees Celsius. And then we subtract 273 from this one, and we get 27 degrees Celsius. So there's our temperature, our final and initial temperatures. So now we plug everything into our equation. So here we've got Q is equal to MC, and delta T again is final temperature minus the initial temperature. So we're going to plug our values into there. So we have a positive 52. So this is 52 joules is equal to the mass, which is 2 grams. So that's going to be 2 grams multiplied by the C, which is what we're looking for. And then final minus initial. So it's going to be final temperature, which is 27 degrees Celsius, minus, and this is where you got to be careful about your minuses and your negatives and stuff like that. So we're subtracting a negative, so we got to make sure we're doing that. So we have negative 13 degrees Celsius. And so there we have everything. So we're subtracting a negative because we have a negative temperature for our initial temperature. So now that we got everything plugged in, all we need to do is figure this out here. Let me see if I got this. So this is going to be change in 40. So this is going to be equal to 2 grams times C times 40. So this is going to be a change in temperature of 40 degrees Celsius. Notice that a minus times a minus gives us a positive, so we get 40. We're going to add those numbers together. And so then we going to have, this is going to be equal to 80 grams per degree Celsius because we multiplied these numbers together. And then that's going to be multiplied by your specific heat. And then we have 52. We're going to take 52 joules, divide that by 80 grams degrees Celsius. And so then the specific heat is going to be 52 joules divided by 80 grams degrees Celsius. And so here we have the units for specific heat, joules over grams degrees Celsius. So we know we did the math right because we have the right units. And so we just calculate this, and this ends up being C is equal to 0.65 joules per gram degrees Celsius. And there you go. That is our last practice problem. I hope that you enjoyed this video. Let me double check, make sure I don't have anything else I need to do. Nope, that is it. So thank you very much for joining me in this video. If you enjoyed this video, if this was very helpful or you got a lot from it, then by all means, please like the video, hit that like button right there. Share this video with your friends, subscribe to my channel, hit that notification bell. If you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think, and if you got any questions, I'd love to hear from you. Thanks for joining me, and have a great day.